Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 18 of our 30 LeetCode challenge, and the problem which has been given to us today is minimum path sum. So we solved this problem, at least the problem similar like this before, so this should be a fairly quick problem. But what I'll try to do is I'll try to explain my approach and try to go into all the nitty-gritty details. And if you still need an elaborate explanation, you can find the link in the description below of my previous YouTube video. Again, if you want to try to solve this problem on your own, do find the link in the description, and let's just get started. So we've been given an m into n grid with non-negative numbers, and we need to find the path from top left to bottom right, which minimizes the sum of all the numbers along its path. And we can only move either down or right at any point in time. So you've been given an example over here, and think of this as a game. So let's say you're starting from this point and you want to end over here. Now let's say that every single step that you take is a cost which is going to be associated to you, and you want to go to you want to take the minimum cost path. So as you can see over here, the best alternative for you would be to go from here and then go down. And that would enable you to have the minimum cost so far. Now, if you think about this as a game, and this is actually a dynamic programming problem, so if you're not aware of that, that's okay. And before we sort of talk about it being a dynamic programming problem, let's talk about it just being like a simple game that you want to play. So if you want to go through all the parts, there would be a few approaches that you would be taking. So some people like to go through the backtracking approach where you say that, hey, I'm going to start from here and I want to reach here. Or similarly, it doesn't really matter, but it's just a thing of preference. So what I like to do is I like to start with the starting point and say that, okay, which are the two possible alternatives that I can take? I can either go right or I can either go down. So if I go down, the present cost would be 2, and if I go right, then the present cost would be 4. Now this would sort of enable me to, if I don't like really contain how much cost has been taken into account for a particular step, and for each step, I would sort of make the mistake and say that, oh, I just need to go down, because I would say that, oh, the cost over here is 2, whereas the cost over here is 4, and that would sort of tell me like, oh, I should go down, but that's not the correct approach. So the next thing that you would want to probably do is you would want to look at what's the next step that you can take. So the next steps that you can take is you can go down from here, which would be a total cost of 6, or you can go right from here, which would enable a total cost of 5. Or you can take this particular case. Now this makes it a lot more interesting, and this is where when I first started doing dynamic programming, I think this was the first problem that I'd solved, and this middle element is what like triggered that switch in me. So let's try to trigger that switch in you as well. So to go to 5, what would be the most optimal way to go to 5? You can go to 5 from 3, where you can go down, so the cost would be 1, 3, and 5, which would be 9. Or you can go from 1, where you can take a simple step on the right. So you would go 1, 2, and 7. So total cost here would be less. So you try to take that alternative, and that would be a better approach for you. That being said, if you go forward, if you go over here, now we know that the minimum cost that we had sort of taken into account over here was 7. Now if you go over here, the most amount of time, or the most cost when you calculate it, comes out to be 8 over here. And over here, when you go from 131, which is 5 in total, and you go down, then the total cost is 6. So this path becomes more optimal in that sense. And I'm just sort of explaining a dynamic programming approach, but I hope that trigger sort of happened for you as well, where you're computing the minimum between these two guys, whatever the path, whatever the cost is so far, and then sort of use that. So in dynamic programming, you would use, or you would associate another matrix, and you'll call it the cost matrix, where you sort of contain all those values. So before we start, we always start with our base condition, which is just going to be like, hey, if there's nothing there, just return 0. The next thing that we need to do is we need to make a cost matrix. So this will be the same matrix as the grid, but all the elements inside this particular matrix should be 0, at the beginning at least. So let's just do that quickly. Let's just do for in range length of grid of 0. So this is just me making all the columns, and this is just making all the rows. You sort of optimize this just by using Python's into function, and that will sort of create that entire thing for you. But I like this approach. It just shows you that you have understanding of list comprehensions. The way you would look at this thing is that this is for one column, and the outer loop is for all the rows which would be in all the rows which will be there. So that will keep on inserting the columns. So you'll have a list of list implementation. The next thing that you want to do is you want to start with the 0, 0 index. That's the starting point. So let's go ahead and make that a value as well. So let's just say cost 0 of 0, which is the starting point, is grid 0 of 0. So obviously there's not going to be any cost over here. Now what we want to do is we want to associate a cost, because the only operations that you can take is you can take either right or you can take down. So what we want to do is we want to create or sort of input into the cost matrix all these values as well. That's pretty straightforward. You don't really need to worry about that too much. So you can just do for j in range of length of grid of 0, which will basically get all the columns. And what we're going to do is for all the columns inside the first row, we're going to append the cost matrix as well. So let's just do 1 comma this thing, because we've already inputted inside this thing. And what we're going to say is cost of 0, which is the first row of the jth column, will be equal to cost of 0 j minus 1 plus grid of whatever is inside the grid right now. So grid of 0 of j. So basically what you're saying over here is the cost matrix will have 1 over here, and then it should have 4 over here. So you're just saying like, hey, whatever the grid's input is, add that with whatever was the previous input and just move forward. So this would be 1, 4, 5. So basically we're just containing what's the minimum cost that we've encountered so far. Since there's no other alternative, that's the only way we can sort of take care of this thing. And the same thing for the rows as well. So let's just quickly do that. I'm just going to do a quick copy paste of a few things. Hopefully I can do this a little quick, because this is almost the same thing. And yeah, and I think that should do it. That should sort of input everything inside the other stuff. Now all you want to do is you want to run a iteration from not from the first part, but rather from this element, because we already had these guys and this guy. So that's pretty straightforward. Just add 1 in front of your range function, and that will sort of enable you to start from there. And the reason why we've done all this stuff is because I want to check what's on my top and what's on my left. So I just want to check those values out, and when I do that, I just want to make sure that I'm getting the minimum value so far. So what we're going to do is we're just going to say cost I of j is going to be equal to grid I of j, which we've already thought about before, because you need to add whatever's inside the grid. But what you're going to add it with is going to be the minimum cost of whatever's on the top, which is going to be I minus 1, j, or whatever's on your left. So cost I j minus 1. And eventually what's going to happen is this entire loop is going to run through, and whatever's the last value inside your cost matrix, once that thing gets appended, because you're going to go through these guys over here, this guy and this guy, when you sort of go through all those, this particular value is going to be your cost matrix, the minimum path which could be taken so far. So let's just go ahead and run this code. Hopefully this should run fine. And also we can see that it's running fine. Let's just go ahead and submit this. Hopefully this should get submitted, and it did, so it's been accepted. And that was basically it. So this is one of the first problems which I had actually solved during my dynamic programming days. And I can see that sometimes it takes a lot of time. But whenever you have something like, oh, you need to maintain, or you need to sort of look for the minimum path so far and all those things, you probably want to use a dynamic programming approach. That's the best approach that you can think of. And that's basically it. So if you had any comments, or if there's something that you didn't understand, do leave it in the comment section below. And if you have any ways or tips for me to improve the video, do let me know in the comments. And if you did like this video, do give a like and do subscribe to our channel. We are discussion over here, and we would love to have you on board with us. And if you've already subscribed, you're awesome. We all know it, and have an awesome day. Thank you.